Part 2. Okay, so if you can recognize right off the bat that I can take the square root of 36 and the square root of 2, so 36 times 2 is going to give me 72, and 36 is a perfect square, I can go ahead and do 6 square root of 2. That's perfectly fine. But if you can't identify that perfect square right off the bat, this is what we want to do. We want to make a factor tree. So, and I start by 2, so 2 goes into 72 36 times, and then 2 goes into 36 18 times, 2 and 9, 3 and 3. So these are all prime numbers. So I'm going to draw my radical, and I get 2 times 2 times 2 times 3 times 3. And remember what we said, it takes a pair to go outside the radical. So I have a pair of 2's is going to go outside the radical, and I have a pair of 3 go outside the radical. These are factors, so I still need to multiply. 3 times 2 is 6. Who's left underneath the radical? 2 is. So I'm going to get the same answer either time. I just can't always identify those square roots right off the bat. So let's look at 63. If you can recognize that the square root of 9 and the square root of 7 is 63, go for it. And then you would get 3 square roots of 7. If you can't, look at your factor tree. We get 3 and 21, 3 and 7. So underneath that radical, I have a pair of 3's that go out, and then I have square root of 7 left over. So I'm going to get the same answer. All right, let's jump to some bigger ones here. Okay, let's do 450. Okay, so I can't recognize a perfect square right off the bat. I just can't. So I'm going to go here, and I'm going to do a factor tree. I go by even. It's an even number, so I know that 2 goes in there 225 times. I know that 5 goes in there because it ends in 5. So 5 goes into 22 4 times with 2 left over. 5 goes into 25 5 times. And then I can keep going by 5 and 9, 3 and 3. So here are my prime numbers. I like to list my prime numbers in order from least to great. So I have 2 times 3 times 3 times 5 times 5. Remember the rule, it takes one pair to go outside. So a pair of 3's and a pair of 5's. And then don't forget these are factors, so you multiply. 5 times 3 is 15. And then you have a square root of 2. And that's my answer. Okay? All right. Now, cube roots, I don't have them memorized up to 10. So I don't expect you to have them memorized up to 10. But remember what a cube root is. It's 2 cubed would be 2 times 2 times 2. So now instead of being squared, which means 2, now it's going to be cubed, which means 3. Because a cube is 3-dimensional and a square is 2-dimensional. That's where that name comes from. So here, I can still do the factor tree. I can still do 8, and I get 2 times 4 and 2 times 2. But now, instead of circling a pair with 2, my number says I need to circle a group of 3. So now I can circle a group of 3, which is 2, and nobody's left underneath the radical. So 2 is, the cube root of 8 is 2. 2 times 2 times 2. So 729. I certainly don't have that memorized. So I'm going to do a factor tree. And what number goes in there? If I add up my digits, 7 plus 2 is 9. 9 plus 9 is 18. If that number is divisible by 3, 3 goes in there. So 3 goes in there 243 times. 3 goes in there 81 times. And then 9 and 9, 3 and 3, 3 and 3. So I'm going to circle all my prime numbers so I don't get lost. So underneath that cube root, I have 1, 2, 3, 4, 5, 6. Remember, this is a cube root. So now it's a grouping of 3 goes outside, and another group of 3 goes outside. So 3 times 3 is 9. So the cube root of 729 is 9. Now, one thing I do want to show you here is on 26, you can't have a square root of a negative 49. It's not possible in Algebra 1. It's not possible because there's not two numbers that multiply together to give you a negative 49. Because negative 7 times negative 7 gives you a positive 49, and 7 times 7 gives you a positive 49, there's no way I can get a square root of a negative number. It can't happen. A cube root, you can. Because you can get a negative 1 times a negative 1 times a negative 1 is going to give you that negative sign. So in this case, my answer would be negative 1 is a cube root of negative 1. So in 26, I can do my factor tree. 7, 8, 9, 10. 3 doesn't go in there. Yeah, no, 3 does not go in there. 2 does not go in there. 7 probably does. Okay, so we're going to do another example. We're going to not simplify. So not simplify that one. All right, let's do number 29. So I have 500 here. It's a cube root, so now it's a group of 3 that comes out. So I'm going to do 2, 250, 2, 125. I know 5 goes in there 25 times, and 5 and 5. So underneath, here are my prime numbers. Underneath this cube root, that's what it tells you the grouping has to be 3. I have a 2 times 2 times 5 times 5 times 5. Here's a group of 3 that's going to come out. And I have 5 cube roots of 4 left over. So one thing I want you to do, I want you to highlight this one. Couple of things. You have to tell the reader that it is a cube root left over, not a square root. Square root's very different than a cube root. So you have your number, your cube root, and then you multiply what's left over inside, and that's how we get 4. Okay, on number 31, if it's negative, that's fine. Take your negative out first. You know your answer is going to be negative. Okay, so I'm going to take that negative out first because I don't want, once I simplify, I don't want a negative underneath that radical. I don't. I want them outside that radical. So for 16, I have 2 and 8, 2 and 4, 2 and 2. So underneath that cube root, I have 2 times 2 times 2 times 2. I know it's going to be negative because it's already decided. So it's a group of 2. So my resulting answer is going to be negative 2 cube root 2 is left over. So this is my final answer. Okay? So simplifying the radical for cube roots very similar. It's just a group of 3 as opposed to a group of 2 for squaring. Practice, make sure you understand what I just said so when we come to class tomorrow you understand. All right, come see me if you don't.